All right, we're looking at the Unit 1 Lessons 16 through 19 practice quiz today. And the first question has the directions to factor completely, and if the polynomial is not factorable, to write prime. So anytime you're looking at a question like this where you're asked to factor, the first thing that you should always look for is to see if there's a greatest common factor. And if you look at the terms in number 1, you can see that there's 4 terms, and they each have x's and y's. So you want to see the greatest number of x's that they all have in common and the greatest number of y's that they all have in common. And you can see that since the last 2 terms only have one x to the first power, there's only one x that you're going to be able to take out. And the first 2 terms only have one factor of y, so there's only going to be one factor that you're able to take out from all the terms for y as well. So you take those 2 out, and then in parentheses, you're just writing everything that's left over. And once you have this stuff in parentheses, there's nothing really that any of these terms have in common. So there's nothing else that you can take out. So this is your final answer for factoring completely. When you get to question 2, if you look for a GCF, you see that there's like a number 4 and an a and a b in the first term. And so you wonder, well, does every term have a factor of a? And you see these last 2 don't. Does every factor have a term of b? No, this one doesn't, and this one doesn't have a b. Well, what about the factors that make up 4? You have 1 and 2 and 4. Does every term have a factor of 2 or 4 or 1? Well, they all always have 1, so that's not really helpful. But do they all have 2? This has a 2, this has a factor of 2, but 3 doesn't have a factor of 2. So there's nothing you can take out that they have in common. So if there's no GCF, what you want to do with 4 terms is factor by grouping. You want to group the first 2 and the last 2. The first 2 terms have a 2a in common. The last 2 terms have a 3 in common. You'll notice when you take out each of those that you're left with 2b plus 1 each time. So the final factorization is 2b plus 1 times the 2 GCFs of the 2 terms, so the 2a and 3. Make sure they're factored. Question 3 says to write each expression in quadratic form if possible. So quadratic form again is ax squared plus bx plus c. The way you can tell if something can be written in quadratic form is that the first power that you see in the function has to be twice as big as the next power. And those can be the only 2 terms in the polynomial that have exponents, that have variables, and there have to be 3 total terms. To write it in quadratic form, it needs to be a times something squared plus b times something plus c. And the 2 somethings that you put in parentheses have to be identical. And if you can't make them identical, then it can't be put in quadratic form. So to put this in quadratic form, you have to call it c to the 4th to the 2nd. And then using an exponent property, you would get 4 times 2, which makes the original 8. And then you can see that c to the 4th and c to the 4th are both in parentheses, so they're identical. You have 4 times something squared plus 4 times something plus 7. This is quadratic form. Question 4 relates very closely to question 3, and it says a proton in a magnetic field follows a path on a coordinate grid modeled by the function f of x equals x to the 4th minus 2x squared minus 15. What are the x coordinates of the points on the grid where the proton crosses the axis? The reason this is similar is because this problem, x to the 4th, is difficult to solve as a 4th degree polynomial, but the power 4 is twice as big as the power 2, so this polynomial can be rewritten in quadratic form. So you can see I did that over here. I have x squared to the 2nd power minus 2 times x squared minus 15. So the thing that's in my parentheses is x squared. So this is now just a basic quadratic where a is 1 and c is negative 15. So I have those. My 2 numbers that multiply to negative 15 that add up to the negative 2 are negative 5 and 3. So my factors are x squared minus 5 and x squared plus 3. Notice that it's x squared because that's the thing that was in parentheses. If I had to factor question 3, both of the factors would start with c to the 4th power. Once you get to this step, you just need to set each of these equal to 0 and then solve. And I don't have that work on here, but when you do solve, you will get plus or minus the square root of 5 and plus or minus the square root of 3 times I. The I solutions are imaginary, and so they're not the graph. You wouldn't see them on a graph because they're imaginary. So the only times you would see the proton crossing the x-axis are the plus or minus square root of 5. That's what I wrote over here. The proton crosses the x-axis at x equals plus or minus square root of 5. Question 5. Use synthetic substitution to find f of -3 and f of 4 for each function. So for synthetic, you have 1, -5, 10. I use those here. I plugged in -3 and 4. I just followed the process for synthetic, and I got f of 3 is 34. That's my remainder. F of 4 is 6. That's the remainder over here. Question 6. Given a polynomial and one of its factors, find the remaining factors of the polynomial. If you are given a polynomial and one of the factors, and you have to find the remaining factors, that is code for do some division. The factor here is x minus 1. So the number that's going to make that equal to 0 is 1, because 1 minus 1 equals 0. So I have 1 in my box. I'm choosing to do synthetic because it's just really easy to do with synthetic division. My coefficients are 1 from the x cubed, 7 from the x squared, 7 from the x, and -15. Plugging that in, I get 1, 8, 15 left over with a remainder of 0. 1, 8, 15 represents x squared plus 8x plus 15. Again, AC is 15. Two numbers that multiply to 15 that add up to 8 are 5 and 3. So the other two factors are x plus 5 and x plus 3. Those are the remaining factors. Over on the back of your quiz. Number 7, the volume of water in a rectangular swimming pool can be modeled by the polynomial 2x cubed minus 9x squared plus 7x plus 6. If the depth of the pool is given by the polynomial 2x plus 1, what polynomials express the length and the width of the pool? Again, you are given a polynomial that represents the volume. You're finding the volume of a rectangular swimming pool. If you don't realize this, they don't give you a formula for volume, so you need to figure out what is the volume formula for a rectangular swimming pool. Well, a swimming pool that's a rectangle has a length and a width and some depth. So the volume, it's basically, you have to imagine, or you can sketch, essentially you're drawing like a box. And the volume formula for that is length times width times height. So this polynomial represents the length times the width times the height, or the depth if you want to use depth instead of height. And if they give you the depth, when you divide out the depth factor of 2x plus 1, you're going to be left with the length and the width, which are the other things that you're solving for in the problem. Because the factor has 2x plus 1, because there's a number in front of the x, I personally think it's easier to do long division. You don't have to do long division. You could do synthetic, but it's an extra step of work to figure out what number would go in the box because it's a little bit more challenging when you have a number in front of x. If you did do synthetic, the number that would go in the box is -1/2. So I have my long division over here. You can follow through the steps. You'll see that I was left with x squared minus 5x plus 6. I brought that over here. I did AC. I didn't write it down. AC is 6. Two numbers that multiply to 6 that add to -5 are -3 and -2. So those are my other two factors, x minus 3 and x minus 2. Question 8. State the possible number of positive real zeros, negative real zeros, and imaginary zeros of each function. So to do this kind of problem, you're going to have to use Descartes' rule of signs. So Descartes' rule of signs says you first look at p of x and see how many sign changes there are. From +2 to -2, it changed. From -2 to +2, it changed. From +2 to -1x, it changed. -x to -1, it doesn't change. There's 3 sign changes here, so that means there's either 3 or 1 positive real solutions. And you don't know if it's 3 or 1 until you go through and do the problem, but that you don't have to do the problem here. To find the number of negative real solutions, you do p of -x. You replace all these x's over here with a -x, and you can see that I did that each time. Then you're doing -x to the 4th power. 4 negatives is a positive, so it keeps the 2 positive. 3 negatives is negative, times the -2, that makes 4 negative signs, that makes positive 2. And then you can go through and see the rest of them. The basic concept, anytime you plug in p of negative x, if the power is even, the sign doesn't change. If the power is odd, the sign is going to change. So this stays the same, this changes, this stays the same, this changes, this stays the same. You can see once we write that out that there's only one sign change here, so there's only one negative real solution. So to find the imaginary or the complex zeros, you have to think about the degree. Well, the degree is 4, so there's 4 total solutions. If 3 of them are positive real and 1 of them is negative real, then there can't be any complex because 3 plus 1 plus 0 makes 4. Or if there's 1 positive real and there's 1 negative real, then you have to have 2 complex because 1 plus 2 gives you 4. Question 9. Write a polynomial function of least degree with integral coefficients that has the given zeros. Hint, this is something I wrote in that I'm not going to write in on the actual quiz. Hint, all zeros must be written as factors in the form of x minus the 0. So if you're given -2 and 3 plus I, you need to realize that 3 minus I is also going to be a factor. These are conjugates of each other. When you do that, so I have x minus the -2, x minus the 3 plus I, and x minus the 3 minus I. You want to FOIL these last two things first. And to do that, f x times x gives you the x squared. The O is x times -3 minus I. That's here. The I is x times -3 plus I. That's here. And the L is 3 plus I times 3 minus I. I did that over here. You can see it ends up being 9 minus I squared. I squared is -1. 9 minus -1 is 10. So that's why I have a 10 here. These things in here, I had to distribute the x. So you can see down here I have -3x plus ix. That came from this first thing. -3x minus ix came from the second thing. The ix and the negative ix cancel out. You have two -3x's, which makes -6x. Then I multiplied everything in here by x plus 2, and I ended up with x cubed minus 6x squared plus 10x plus 2x squared minus 12x plus 20. Notice that I lined up the powers. First powers are together, second powers are together. When you combine your like terms, you get x cubed minus 4x squared minus 2x plus 20 as your final answer. Question 10. List all the possible rational zeros of each function. To do the possible rational zeros, you have to do the p over q. P is 7, q is 3, and list the factors of those numbers. 7 is prime, so it's only 1 and 7. 3 is also prime, it's just 1 and 3. And then p over q, you could have 1 over 1, 7 over 1, 1 over 1 over 3, and 7 over 3, and positive or negative all those, so I listed them over here. Question 11, find all the rational zeros of each function. So for this, you're not just listing, you need to start off by listing the possibilities, and then choose something from the possibilities and see if it's a 0. So my p is 12, my q is 1. I listed all my possibilities right here, 1, 2, 3, 4, 6, and 12. And then I did Descartes' rule of signs also. I noticed that there's 2 sign changes in the original and 1 sign change in the negative version. So there's either 2 or 0 positive reals, and there's always 1 real solution. So I was like, okay, let me just guess a positive number. I probably started with 1 and it didn't work, and then I tried 2, and you can see down here in my synthetic division that 2 does work. So I got 2. When I did the division, I was left with 1, 1, -6. That makes x squared plus x minus 6. AC is -6. Two numbers that multiply to -6 to add up to 1 are 3 and -2. So I split my factors into x plus 3 and x minus 2. And the solutions that make those equal 0 are -3 and +2. Notice that 2 comes from here, but it was also over here. So the 2 solution is technically repeated twice, but you don't have to list it twice. I'm going to run out of time on the video, so I'm going to stop the video now and then do question 12 in another video.